let's get going. So the main idea with probability, as I said in the last lesson, is how do we quantify uncertainty? And the main formula we use is how many possible outcomes are there over how many favorable outcomes are there. And what it means to be favorable depends on the event that you're talking about. So how many favorable outcomes are there for some event? Often I use the symbol like A. And in terms of the formula, that could be written as the probability of A, favorable A, number of possible. And another way of writing this is that number of items in A over the number of items in S, where S is the sample space of all possible outcomes. Okay, so that's the basic formula for probability. What we need to work on today is different ways of visualizing possible outcomes and favorable outcomes. And so the focus today, after a little warm-up, is going to be on something called a Venn diagram. And in a Venn diagram, the set S is the sample space. Events inside the rectangle are often written with circles like that. That would be this event A. This would be the event B. And this region here is an item that is both in event A and in event B, or in the intersection of two events. Okay, so that's the basic warm-up. Give me a thumbs up if those ideas look familiar to you. Give me a thumbs down if those ideas look unfamiliar to you. Okay, well, let's do a little warm-up to make sure we are familiar with this formula. So which of the four options do you think is correct for this question? It's a basic probability question. Which of these four do you think is correct? How many possible outcomes are there? How many favorable outcomes are there? And then put your answer in the chat. And as I look at the chat, I see lots of people are saying B. I got 2 out of 5, which is B. Yeah, okay. So this is an example of us using the basic probability formula. Let's do another one, and then we can move on. What do we think is the correct answer for this one? So there are 8 colored roses, and they're made up of 1 yellow, 2 red, 5 blue. What's the probability of picking a blue or a yellow? So yellow is 1, blue is 5, which gives us 6 out of 8. But it says leave it as simple as possible. And so even these are both correct, but given that the question says the simple as possible, that would be simpler. So both these are correct, but it's just a sneaky thing that says leave it as simple as possible. Okay, so, all right, so that's the warm-up done. Let's go on to let's leave that last bit out there. Let's go on to this. So this is a very simple Venn diagram, and I want to ask, the sample space is S, is the region around the outside. So those items. The items that are in both A and B. Which items are in both A and B? If you look at the the sets A and B. So Khalid has said 1 is in both, 3 is in both, 5 is in both, 7 is in both. So with my Venn diagram, we would say 1, 3, 5, and 7 are in this region, the intersection of A and B. What is going to be in this region over here, which is only B and not anything else? Well, it's all of B that's not in A, is another way of saying it. Okay, we can see that that would be 9. It would be the item 9. What is going to be over here? What's in A but not in B? Okay, so this would be 2. Is there anything that's not in A or B? If you look at this collection. Is there anything that's not in A? No. Okay. So there's no item that isn't in A or B. All of the items fall in that. Okay, some more vocabulary about stats and probability. What is the number of items in A? And what is, yeah, let's do that. What's the number of items in A? So there are actually going to be 5 items in A because there's 1 here and there's 4 over here. How many items are there in A and B? How many items are there in A and B? So visually, that would be items that are in A and B would be this region here. And so we would say there are 4 items there. Okay, how many items are there in B dash, or what we would call the complement of B? Or how many items are there in the sample space that are not in B? So not in B is going to be everything outside of B. And the only item I see is 2. And so there's 1 item there. And the item that I was looking at was this one. Okay. Let me do a probability one. What is the probability of ending up in A, of getting an item for either A or B in this Venn diagram? What if you were to choose one number from this collection? What is the probability? Now it's different. It's not n anymore. It's the probability. And remember the possible outcomes. There are 6 possible outcomes if I look at the Venn diagram. What is the probability of being in A or B? I'm being a bit sneaky rotation because I just want to make sure everybody understands how it works. Well, the number of items in A or B is actually just, so if I had to work out the n of A or B, so how many items are in A or in B, it's going to be 6. How many items are there in total? There's 6. So there's 100% chance if you draw from this collection, you'll get an item in either A or B. So that's me being a little bit sneaky, just to see how well you understood the words and or. Give me a thumbs up if you followed the basic logic there. Give me a thumbs down if you unsure about this. Okay. Okay, so let's give you a bit more control. Don't worry, you have plenty of chance to practice this. So here is the situation. I want you to draw a Venn diagram to show the sample space. And the sample space has the numbers 1 to 10. Inside the sample space, event A is the set of prime numbers. So prime numbers. Event B is the set of even numbers. Start by drawing me a Venn diagram that describes this. And when you are done, just say done in the chat. Oop. So your sample space with Venn diagrams will always be a rectangle. And now the question is, I suppose we should ask, are there any items that are in both A and B? Because if there's an item in both A and B, and I do notice one, the one I notice is 2. And so because there is an item that is in A and B, we can have overlapping circles. So that would be a 2. Now, if I should label this A and that B, so that would be 3, 5, and 7. And this would be 4, 6, 8, 10. Are there, so I think I'm seeing quite a few dones coming through in the chat. Are there any items that are not in A or B? Are there any items that are not in A or B? Well, I definitely noticed 1. So the 1 is sitting out here. And Uwetu and Lerato are on it like a flash. There's also a 9. Okay, so we have 10 numbers in a hat or in a space. And now we figured out how many items there are in each region. And this is where the Venn diagram does such a good job. It shows us how many outcomes there are in different areas. I want you to work out for me the answer to what is the probability of A occurring. So basically, if you're choosing an item out the hat, what is the probability it is a prime number? And I want you to do these 4 questions by yourself and just put the answers in the chat so I can see how you're going. And as always, if you're unsure, put your hand up and we can chat about it. But I think I've given you enough scope to get this one. And I'll just watch the chat for now. I'll even make my question a bit bigger so you can see. I want you to answer those questions there. And I see Sate's got an answer, and Fazama's got an answer, and these are definitely all going to be out of 10 because there's only 10 numbers. So the question really is about the topics here. How many items are there in A? Well, there are 4. So, or you could say 40% chance of being in A. What about B? Oh, well, B's got 5. So that would be 50%. Or half is another way. Now, how many items are in both A and B? Well, there's only the two, so there must be a 1 in 10 chance or a 10% chance. I mean, basically, that I choose a number that is both a prime number and an even number. And what is the probability I will choose either something that is a prime or even or both? Well, if you're prime, you're in A. If you're even, you're in B. I'm really worried about how many items are in A or B. It can be anywhere here, and I see 8 items. So there's an 80% chance you'll get a prime number or an even number or both of them. Okay. So this is an example of Venn diagrams being put to use. There's a couple of identities that sometimes come in with Venn diagrams, which I'll write out for you now. Just give me a thumbs up if you're following, though, and thumbs down if you're feeling unsure about anything. So probably one of the most common identities in probability is this one. Minus n. So it's called the additive identity. And just so you kind of know what's going on with this, I'm just going to quickly explain it. How many items are in A or B? Well, there are going to be 8 items there, if you look at that. How many items in A? There are 4. How many items in B? There are 5. How many items are there in A and B? There's just 1. So if I apply this identity to this, can you see how 4 plus 5 minus 1 still gives you 8 on both sides? And so another way that this identity comes up is sometimes you see it written like this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is often, people learn these formulas, but they don't really understand where they come from. So just to show you how this works in this situation, well, the probability of A or B was just 8 out of 10. The probability of A was 4 out of 10. The probability of B was 5 out of 10. And the probability of A and B was just 1 out of 10. So what you see is the 10 comes from the fact that there's 10 items in the sample space. And because these events overlap, you have an item, you have to subtract the intersection of the two sets. And so I'm not going to say too much about this for now, but I just wanted to make these formulas a bit clearer in case your teacher went too quickly in class. Give me a thumbs up if you sort of connected these formulas to the drawing. Give me a thumbs down if you don't see the connection between the drawing and the okay. And then maybe one more little bit of theory. If you have events where A and B do not have an intersection, right? So let's say, for example, if you had an event like throwing a dice and you had odds and evens, where A was just the even numbers and B was the odd numbers, these events are called mutually exclusive because if you get an even number, you can't also get an odd number. The moment you're in one event, you can't be in the other if the events are mutually exclusive. So that's called mutually exclusive events, whereas these events are not mutually exclusive because they have some event, like if you got a 2 here, it would be in both A and B. And again, that's vocabulary that I feel students don't always understand. And so I'm just going to make a note of that as we go. All right. Enough vocab, time for more maths. I want you to draw the Venn diagram for this question. And when you're done, just done in the chat. So I think the easiest one to do first is the 23, but then to work out how many people like comedy, but don't, I mean, like action, but don't like comedy. Well, 55 like comedy, 80 like action. So I guess action just has to be 80 minus 23, and comedy just has to be 55 minus 23, because together that will give you the 55 for comedy. So if we could just hit mutual there, I think there's been a bit of a thing there. 35 minus 3, so that's 32. And this one over here is going to be 57. Now, it is possible that people don't like action or comedy, which would be the region out here. Does anybody have an idea of what this region out here would be and how we would get it? So I think the key bit is to realize there's 150 people in total. And so all I need to do is take away all the regions I've got, which, judging by the chat and the fantastic replies we're getting, 38 is out here. Okay, so now time for a probability question. What is the probability that somebody does not like comedy? Does not like comedy. What's the probability that a randomly chosen person, you ask what movies do you like, and they say they do not like comedy? How do you know when to subtract? Sandesile. So the reason we subtract is we know the total is 150, and we know that there's 32 in this region, 23 here, 57. So if we take 150 minus these guys, what's left, the 38, must be on the outside. So for this one, we know there's 150 students that are being asked, but how many of them would not say that they like comedy? How would I work that out? Well, it can't be in circle C. So the only items that are not in the circle C are going to be the 57, but don't forget about the people who don't like anything, because they don't like comedy. So we get 95 out of 150. So the probability of getting someone who doesn't say they like comedy is pretty high. It's pretty close to 66%. Okay. Well, I think that that makes sense. Maybe we can squeeze in one more before the before the break. Let's do this multiple choice question and then we'll take a break. See if you can tell me which answer you think is correct here. No, Pilo, you can indeed use the formula 1 minus P probability of C. Yes, that would work fine. You absolutely can. So again, it says 150. So if you're working out the probability, the sample space is 150. Well, how many people will choose to study Spanish? So it looks to me like it would be 30 plus 23, which is 53 out of 150, which is C. Cool. All right. I'm liking what I'm seeing. I think it's time to give ourselves a brain break, and you've done really well. So let's stand up, turn on those cameras. Let's see if the power is back on. It is back on. Yay. And join me with standing up and just rolling your shoulders to start with. So stand up nice and straight. Just roll those shoulders back. And then let your eyes focus somewhere in the distance so that they get a break. Okay, and then you can change the direction of your shoulders while you roll them. Okay, and then shake up the arms, make them nice and loose like jelly, shake out the legs, shake them out so there's some blood flow. Let's do a little twisting. So we start off with just a little bit of rotation, and then as we get more comfortable, we can do that. Oh. Let's do some tricep stretching. Okay. You should feel the muscles in the back of your shoulders get a nice release, because when you hunch over, this is the muscle that gets a bit. Ooh. And then on the other side. Oh, this feels good. And let the arms out. Just shake them out again. Okay, let's get our heart rates up. So let's do some skipping. The jumping jacks is a bit too much for today. So start in 3, 2, 1. Let's go. Halfway. And sit on down. Okay. And let us have a little go at a problem. I'm bringing back an old favorite called Maths 24. See if you can solve any of the Maths 24 puzzle questions on board. All you have to do is make 24 using the 4 numbers. See if you can do it.
Mr. S, there's a question for you in the chat that if you actually do these exercises with your physical classes.
I do. So especially when I have doubles. So I don't know if you have doubles. So what I do is I sometimes do some other stuff too. It's not always possible in the time. So I do the pen flipping quite a lot with my physical classes. They roll their eyes at me, but I just lean into it. So I do it. But I force them to, because I know it'll be good for them. So yeah, I do indeed. So Maths 24, the way it works is you have to try and take 4 numbers and make 24 using just those 4 numbers. And there's 3 levels of difficulty. The easiest is red, then blue, and then yellow. So Nkosi has just given an answer, I think, for the yellow one. Let's have a look. So 9 times 4 is 36. And then 3 times 4 is 12. So you've used up that. And then 36 minus 12 is 24. So Nkosi has claimed the yellow Maths 24 card. And then for the blue one, Paul has said 5 minus 2 is 3. And that is times by 6 minus 2. No, wait, hold on. 6 plus 2, which is 8. And so in Paul, you're quite correct. Blue is that. Can anybody do the red one? Normally the red one is the first one we get. Today we're doing it a bit backwards. I see Andile, Olwetu, Oratile have said, I go 8 minus, no, wait, no. 8 minus 7. 8 minus 7 is 1. And then, of course, and then you go 8 times 3. And because this is 1, it doesn't affect anything. And so we get 24. And it's just a fun puzzle game to play to kind of get your brain, just to keep those multiplication facts floating around in your brain. They are very useful. Okay, nicely done, Emmanuel. Okay, break time is over. It's time to head back to probability. I hope that you feel like you've had a bit of a break. Let's go to this question. Complimentary. Can you do this question for me? So you're given, it's slightly different the way it's worded. In a group of 50 learners, 35 take mathematics, 30 take history, 12 do not take mathematics or history. So step 1, draw the Venn diagram. When you have drawn it, just type Venn in the chat, and I will draw the Venn diagram with you before we go on to question 2. If you are smashing this, you are welcome to do question while you wait. Okay, see if you can interpret this question. So, all right. So, Olwetu, what is different about this particular question? This is a little bit harder. It's not crazy hard, but it's a little bit harder than the last one. What makes it harder, do you think? Don't worry, I also got kicked out. We're all got, yeah, you have to work outside in, exactly. Or it's almost like they say 12 learners do not take mathematics or history. So the 12 is like they normally give you the middle, whereas here they give you the outside. Or, you know, and now we have to figure out what are these 3 regions here. And there's a couple of different techniques that people could use, but I think a lot of students benefit by making this middle region that you don't understand X. Well, not because you don't know what it is. And so how can you use that to help you? You know, 12 don't take maths or history. Don't worry, Andile, I also got kicked out. We just still on the Venn diagram question. I think, I don't know what happened in terms of, there must have been some technical issue. But we'll just wait for everyone. I can see we're only missing about 10 more people. So we'll wait for them to join. Then we'll finish off this Venn diagram. How do you know they intersect? Ooh, that is a good question, Paul. Okay, so in some ways, the reason I know they intersect is like you have 50 in total, 12 don't, so there's 38 that do mathematics or history. And so because you know that 38 have to go into this, if you had 30, okay, and you had take history and 35, okay, well, the way to do it, if this was 35 and this was 30, can you see that it is already greater than the 50 students in the actual place? It's a really good question though, Impor. So if there was no intersection, if 35 only took maths and 30 took history, you'd already broken the question because of the fact that there are only 50 in total. So the only way to resolve that is if there is something in the intersection. But I love that question. Watu, yes, let's unmute Watu. See if we can do that.
Good evening, sir.
Say that again.
Okay, so I
Huh?
was greeting everyone.
Oh, brilliant, brilliant, brilliant.
Hi.
Very good.
Okay, so the way I decided to solve this was that isn't it we're given the 12 that do not take mathematics or history? So I decided to add the 35 that take mathematics and 30 that take history and subtract 50 and subtract 12 from the 50, and I got the intersection in the middle.
Okay, brilliant. So I think I would have done it probably a similar way. The way I was going to suggest to everyone now was saying, look, if in maths, 35 take maths, and this was 35 minus x, then 35 minus x plus x gives me 35. And if you then take 30 minus x plus x, you get your 30 and your 35. So that's what I was going to do. There's many ways you could do that. Now, you still haven't got the value of x yet. So what you need to do is you say, well, 12 plus 35 minus x plus 30 minus x is equal to what? Well, it's equal to the total of the whole thing, which is 50. Give me a thumbs up if you followed my thinking for making this add up to 50. Give me a thumbs up if you followed my logic. Give me a thumbs down if you are unsure. So once I've got that done, now I need to go on a mission to find x. But the good news is it's just an equation. So minus x plus x. And now what is 12? So 12 plus 35 plus 30, that gives me 77 minus x is 50. And then I'm going to get 77 minus 50 is x. So x is actually going to be 27. So x is going to be 27. And if I know x is 27, then this is going to be 3. And this is going to be 8. Now, there's a couple of ways we could do that. But that's what I think I would do. But there are other ways of doing that. Now, I want you to work out if a learner is chosen at random from this group, what is the probability that they take mathematics and history? What is the probability they take mathematics and history? See if you can put the answer in there. Please explain the 8 and the 3. Oh, okay. So what we had to do here was this used to be 35 minus x, and this used to be 30 minus x. Because of the 35 for mathematics, that's where that 35 comes from, and the 30 for history, that's where that comes from. But you know x is 27, so 30 minus 27 is 3. And 35 minus 27 is 8. Now, the answer to this question is there are 50 possible students, and 27 of them take both mathematics and history. And so the probability is 27 over 50, or 54% would be another way of saying that. Okay. So let's move on to another type of question like this, just to get some more practice before we run out of time. And this is just going to be, let's do this one. This is not actually probability. This is just counting. It says, in a class, there are 11 students who study French and German, 5 students who do not study a foreign language, 14 who study French, 24 who study German. How many students are there in the class? There's a couple of ways you could look to solve this as a Venn diagram. So we could do it French and German, so F and G. Or you could use the identity which says the number of F or G is equal to the number in F plus the number in G minus the number in F and G. Both of those would work. I'm going to visually help you with this. So 11 students study French and German, so there would be 11 there. 5 students do not study a foreign language, so they'd be up here. 14 students study French, so 11 there, so that has to be 3. And 24 students study German. So if that's 11, this would have to be 13. So in total, we would get 5 plus 3 plus 11 plus 13, which would give us 32, which is C. So it's important to know your identities, but a lot of the time with Venn diagram, most students find it easier to just fill in the values on the picture. But just remember the connection between this and this. Okay, cool. Let's do another one. Let's actually wait. Let me choose one that has. Okay, let's do this one. This is more interesting. 150 people were asked if they own an iPhone or an iPad. 42 owned an iPad. 71 own an iPhone or an iPad, but not both. And 16 owned both. Which Venn diagram do you think is correct? Now, this piece of information isn't that useful because you can see it's correct in all of them. So 42 own an iPad. Well, that takes out that one. It takes out that one. It can only be B or D. Because remember, if 42 own an iPad, you can't have 42 and 16 adding up to 42. So the only options I think are B and D. Now, the piece of information that helps us, 71 own an iPhone or an iPad, but not both. So I need to see, you either own an iPhone or an iPad, but not both. Well, I can see 26 and 45 give me 71, and I'm not allowed to have 16, so it must be D is the correct answer. That was a sneaky question, but I liked it. It made me think. I hope it made you think as well. Okay, this is a bit like this. Sipa Sikle, I see your hands up. Let's unmute Sipa Sikle. What is your question? I don't know if you can hear me. I'll unmute you there. Can you hear me, Sipa Sikle? Okay, maybe there's a bad connection. I'll just
Sir, yes, I can hear.
Oh, you can hear me. Okay. Yeah. What was your question?
45.
Oh, 45.
Yes.
What about that?
Yes. How did you get the 45? Why isn't it the 71?
Okay. So it's because if you 71 own an iPhone or an iPad, but not both, basically, if you own an iPhone, okay, but you don't own an iPad as well, you would be that region, 45, okay? Because there's 45 people who own an iPhone, but there's another 16 who own an iPhone and an iPad, but we're ignoring them. Then there are 26 people who own an iPad, but they don't own an iPhone. And I know that 26 and 45 together will give me 71, which is what the question said.
Yes.
Does that make sense?
Yes.
Because
Yes. Thank you.
Pleasure. Okay. Let's go. I want to show you. I'm going to do, let's do this one. So I'm going to do a couple more before we finish off tonight. Which of the options below does this diagram match? We've colored in the gray bit is what I'm interested in. Which of the 4 options is relevant here? Which set notation is represented on this diagram? Now, just to kind of explain the symbols, the AND symbol is that, the OR symbol is the happy one over there. And the NOT symbol is the dash or the complement. So this is actually just A or B, which is going to be that one there. It's just A or B. It's just written with it's slightly different notation. And I just think about, so AND is the unhappy face and OR is the happy face. What about this one? What picture, now it's the gray stuff that you want to describe. What would describe that region there? Now, it's basically saying everything that isn't in B. And the way we would describe that is B dash or the complement of B. And so it would be D. Okay, so you've got this. This is good to see. What about this one? What would that, now there's 3 events, and this is what we're going to finish off with tonight is, and the next lesson is going to be focused around 3 events. What would the region be here? And what this is saying is you're inside the event A, you're inside the event B, and the event C. We would call this, so you're in A and B and C. And using the language they're using here, we should be looking for something which is the intersection of A, B, and C. Is there anything like that? Well, it's not that one, because there's no complements. It must be B. So this is the region this is the only part that's in A, B, and C. Okay, you've done that one. I'm not going to worry about that. I want to just show you one to finish off with where you have 3 learners. I mean, 3. Not that. Okay, here's the last question for tonight. So it says here, a survey is conducted with a group of 50 learners to find out what is more popular at the school tuck shop. They are asked if they usually buy toasted sandwiches T, salads S, or burgers B. They can choose none, 1, 2, or 3 of the meals. The Venn diagram, okay, first of all, let's ask this. How many people did not buy salads, toasted sandwiches, or burgers? So let's do that one first. How many people did not buy salads, toasted sandwiches, or burgers? So I know there are 50 people in total, but I want to know who doesn't buy a salad, a toasted sandwich, or a burger. So I guess I have to minus 15, minus 2, minus 3, minus 1, minus 10, minus 5, minus 4. Because I've got to get rid of I've got to subtract all of these things. And whatever is left will be out here. So what are you getting? All right. It seems to be common consensus that the people who don't want to eat any of the 3 meals is 10. What is the probability that a learner selected from this group buys salad, but not toasted sandwiches or burgers? So what's the probability that they buy salad, but not toasted sandwiches or burgers? And we know that the possible outcomes are 50. What is the region that represents buying a salad, but not toasted sandwiches or burgers? So a salad is S, but I'm not allowed to be in burgers, and I'm not allowed to be in toasted sandwich land. I have to, the only region that I'm allowed to pick from is that region, which is 10 out of 50. Okay, what for number 2, what is oh, Kia, you can just put the link to in the chat. We're almost done. I see we're running out of time. For this one, it's also going to be out of 50, but what is the answer going to be for 2? Buys toasted sandwiches and salad, but not burger. Toasted sandwiches is this one, and salad would be that one, but not burgers, so I can't be there. It can only be that region there. So buys toasted sandwiches and salad. So buys toasted sandwiches and salad, but you're not allowed to be the burger thing. So if it was just toasted sandwiches and salad, it would be that, but you're not allowed to be in B. So it has to be, here, just make sure you're not the host in case, just first, but not the burgers. So what are we going to get for that? The key thing is and. So the answer here is actually going to be 2 out of 50. So we get 2 out of 50. And does everyone get that? Like, why it has to be 2 out of 50? Okay. I'm going to finish with this one. I'm not going to do the third one. So buys toasted sandwiches and salad. So first of all, toasted sandwiches is that circle, salad is that. Can you see that this region here are the people who buy toasted sandwiches and salad? Now, I want the people who buy toasted sandwiches and salad, but they're not allowed to buy burgers. So I actually have to exclude the 3. So I get rid of the 3, and the only region that is between toasted sandwiches and salad, but not in the B circle, is going to be 2. And so that's why I would get 2 out of 50, because there's 50 people in total. Okay, does that make sense? All right, everyone, I've squeezed a lot into tonight's thing. I hope you enjoyed the lesson.